Hey everybody. So homework problems from 4.1, and we'll look at a couple of types here. So the problem I'm giving you is a candy company claims that 40% of the candy that they put into a bag is cherry flavor, everyone's favorite. So they're making sure that most of the candy in that bag is what everybody wants. So you find a bag of candy that contains 106 pieces of cherry and 63 pieces of orange, 94 pieces of grape, and 60 pieces of lemon. Is their claim of 40% being cherry reasonable? So what we're looking at here is the probability of cherry equaling 0.400. And all that I did was rewrite 40% as a decimal. In most of your problems, they'll take it out three places. So what we know with probability is this basic formula. Okay, so the probability of any given event in the numerator is the favorable outcomes, and in the denominator is the total possible outcomes that you can have. And when we talk about favorable, don't lots of times we say the word favorable, that means something that we want. But in statistics, that means just what you're looking for. So to be honest with you, it could be something morbid like you're looking at vehicle fatalities. That's not a favorable outcome. But if that's what your study was on, then that's what you call your favorable outcome. Now, I need to take that and I need to convert it to my actual problem that I'm dealing with. Pause the video, see if you write out the same thing that I have. All right, so what I'm trying to find is the probability of cherry. And what that breaks down into is the number or the pieces of cherry candy in the bag in relation to the total pieces of candy that's in the bag. Okay? So, and I want to point this out that my numerator is like x. X is what we're always trying to find in these statistics problem. And my total, my sample space, my universe, my set is always written as n. So that's what those are. So if I were to now replace those words with numbers, I have the probability of cherry being equal to, so my number of cherry pieces was 106, and then my total number is simply all of them: 106, 63, 94, and 60. So let's see, that's 106, and we will use the calculator on this. 106 plus 63 plus 94 plus 60 gives me 323. So 323 total pieces. Now I simply divide 106 divided by 323, and that gives me, we'll take it out three places, so 0.328. So that right there, that's approximately 33%. So approximately 33%. I use the percentages because I can see those in my mind better. Your answers, whenever, and especially whenever you're really doing scientific, analytical statistics, you don't use percents. Most of your work is in decimals. But that helps me to be able to look at it. And really, this is an opinion based thing. I would say no, it's not reasonable. It's 7 percentage points different. Now, granted, this is only for one bag. This doesn't mean that their claim is a lie, but something could have just went wrong with that bag. I would need to test more and more bags of that to see. But for this particular bag, no, I don't think it's reasonable. Maybe if they had 37, I could say okay. But 33, it's 7 percentage points lower. So one other thing that I want to be able to talk to you about with just this problem is the complement. Complement. And what you have, a basic formula, is that you have the probability of some event plus the probability of not that event. And you add those together and it equals 1. Okay? That's the complement. Because what we know in probability is that our probability ranges from 0 to 1 as a decimal, percent, 0% to 100%. So whenever you read something and they act like it's statistically calculated and it's over 100% or less than 0%, that's really not true. Our probabilities range from 0 to 1 or 0% to 100%. So what I'm saying is that if I have two things, something as simple as left hand, right hand, it's left hand and not left hand, or right hand and not right hand. They get a little bit more complicated, and that's why I wanted to show you this. And what I'll do is I'll just use a Venn diagram to illustrate. Is that this is my universal set, okay? And inside my universal set, well, what that is that this is the bag of candy. That's my universal set. It's everything in my universe. All my total possible outcomes are contained in that bag of candy. And in there, I have the probability of cherry and the probability of orange, probability of grape, and the probability of lemon is how I can view that. Or for this problem, or talking about the complement, how I can view that is simply like this. Again, this is my universal set. And what I have here, this is what I'm talking about, are my cherry pieces. So I could call that, say, the probability of C. But then outside of that, everything else is not cherry. I can group orange, grape, and lemon into not cherry, and it contains everything else which completes my set. So, taking what we had here and looking at it, the probability of getting cherry is 0.328. So, looking at the complement for cherry. Oh, let me slide that up, so I'm sorry. The complement for cherry, and I'll write out the formula using C for cherry plus the probability of cherry plus the probability of not being cherry is equal to 1. So I calculated my probability of cherry 0.328 plus whatever's not cherry. If I add all of those together, I'm going to get 1. So how do I find that? I subtract this from both sides. So the probability of not getting something cherry is 1 minus 0.328. 0.672. So around 67% of not getting cherry. Alright guys, homework from 4.1 is fairly straightforward, and what it is it's leading up to the work in 4.2, 4.3, and 4.4. So watch your publisher's videos, structure your homework, think about what you're doing. Good luck with your homework.